Imagine trying to build the entire universe from scratch. For a century, physicists used a master blueprint, the standard model of cosmology. These math equations acted as an architectural guide. For decades, this plan reliably predicted everything, from a fraction of a second after the Big Bang to the orderly galaxies we see today. To finally confirm this blueprint was completely correct, scientists built the ultimate building inspector. The James Webb Space Telescope is a $10 billion machine designed to peer deeper into space. But when they turned it on and looked into the dark void, the numbers coming back didn't match the plans at all. This discrepancy triggered a scientific crisis. The raw data suggests several of our core assumptions about how the universe works are simply wrong, forcing researchers to rethink how the cosmos was originally built. The first major crack in the math involves the Hubble constant. You can think of this as the cosmic speed limit, the exact rate at which the universe is expanding outward right now. According to our master blueprint, we can look at ancient radiation from right after the Big Bang, run the math forward, and predict exactly how fast that expansion should be today. The answer it gives us is exactly 67. But when researchers used the new telescope to measure the universe as it exists right now, using nearby pulsing stars as a guide, the expansion speed actually clocked in at 73. To most of us, a gap of 6 kilometers per second sounds small, but in physics, a difference like that between the math and the reality indicates a massive structural failure in the theory. For years, astronomers hoped this was just an optical illusion. The older telescopes we used often blurred nearby stars together in crowded, dusty galaxies, which can create a bright glow that throws off the calculations. However, the James Webb Telescope uses incredibly sharp infrared cameras to cut right through that cosmic dust. It eliminated the possibility of an error and confirmed that the higher expansion speed is real. Because the universe is flying apart faster than the math allows, our entire understanding of cosmic history shifts. It changes our estimates for the age of the universe and the distance of every galaxy we've ever mapped. The second problem appeared when the telescope looked back at the absolute earliest days of the universe. The master blueprint states the young universe should only contain tiny, dim, infant galaxies, but Webb found monsters. Just a few 100 million years after the Big Bang, it spotted massive, fully formed galaxies that shouldn't have had time to grow. Our own Milky Way took about 13 billion years to reach its current size. These ancient structures had somehow reached that same level of maturity in a tiny fraction of that time. To grow that fast, these galaxies would have had to convert every scrap of gas into stars with perfect efficiency. Most galaxies are actually quite wasteful, so finding these flawless factories in the early universe defies our current understanding of physics. Scientists initially thought these might be illusions caused by bright black holes hiding inside the galaxies. But even after accounting for that extra light, there are still roughly twice as many massive galaxies in the early universe as the model predicts. It wasn't enough to completely break the model, but it was enough to bend it. The early universe was clearly churning out stars much faster than we ever thought possible. It isn't just the timing that's wrong, the actual shape of the building materials is defying the plans. Our standard blueprint relies on an invisible scaffolding called cold dark matter. This material is supposed to act as a heavy, slow-moving anchoring that pulls gas together into round, orderly galaxies. But the telescope found that many early galaxies are stretched out like cosmic cigars. These elongated shapes suggest that the dark matter scaffolding isn't clumping together the way we thought it would. This cigar-like shape matches a second, quieter mystery. When scientists measure how matter clusters together across space, they find that the universe is actually much smoother than the master blueprint says it should be. If dark matter behaves differently than we assumed, it changes the foundation of everything. You cannot swap out the structural core of a building and expect the rest of the skyscraper to remain standing. With the math broken and the foundation in question, do we have to throw our century-old blueprint in the trash? No, the plan still works for the basics. It still accurately predicts things like the amount of hydrogen and helium left over from the start of the universe. Instead of starting over, researchers are trying to add a new page to the plans. The leading idea is something called early dark energy, a hypothetical, temporary kick of expansion that happened right after the Big Bang and then vanished. A cosmic kick like that would have rippled through time, adjusting the math just enough to explain why the universe is expanding so fast today without breaking the rest of our physics. Nobody has detected this unseen energy yet, but the James Webb Telescope was built specifically to find these cracks in our knowledge. Now it's providing the data we need to draft the next page of the cosmic story.